zero.
That was Mangalyaan, the Indian Space Research Organization's Mars orbiter mission. Not only was it India's first attempt and a glowing success at that, it was the first country to achieve success at this feat the very first time it did so. With inspiring feats like these every year, ISRO has grown to be one of the world's most premier space organizations. But there was a time when India's space dream was deemed impossible. There's an impressive story behind how it was achieved, and this is that story. The story of how a country that could barely walk at the dawn of its independence soared in space. The story of the vision of a young man and how it helped an entire nation's dream come true. My name's Pranav, you're watching Science is Dope. Let's begin. This video is brought to you by my supporters on Patreon, Buy Me a Coffee, Nas.io and YouTube. If you wish to support me, you can find the links below. Our story starts in 1937, Cambridge, England, where a young man had come to study with ambitions of making his mark in the world of physics. Cambridge was a place to be if you were an astrophysicist, like our young protagonist. There were so many things happening in the landscape of physics, be it relativity or quantum mechanics or nuclear physics or cosmic rays. This made physics all the rage. People like Einstein and Heisenberg and Rutherford had made their name and fame in physics just a few decades earlier, and our young protagonist was determined to put his name in that list. He chooses cosmic rays as his area of research, but unfortunately for him, his stay in Cambridge gets cut short when in 1939 World War II breaks out. It almost looks like every country in the world is on some or the other side of the war, and this makes travel very difficult. But under the request of his father, Ambalal Sarabhai, he comes to his home country of India. And the son, our protagonist, Vikram Sarabhai, gets sent to the Indian Institute of Science, Bangalore. There he continues his degree under India's own star physicist and Nobel laureate, C.V. Raman. But it wasn't a meeting with Raman that changed his life. There was someone else working in IISc at that point. It was a meeting with him that would change Vikram Sarabhai's life forever. Who was he? One of India's leading scientists, someone who would go on to become the architect of nuclear science in India, Homi Jahangir Bhabha. This meeting would go on to change not only their own lives, but the lives of millions, no, billions of Indians. Let's see how. Even though they had a 10-year difference in age, the two strike up an instant connection thanks to the similarity of their past. They both come from influential family backgrounds, both of which played an important role in India's freedom movement. Their upbringing and education, for instance, they both studied at Cambridge, and although they never met there, this becomes a point of connection between them. In addition, their mutual love of culture, which they engaged in by attending shows and plays across the city, and most importantly, their area of work. They were both physicists. Around this time, their country is also on the verge of independence from the British, and the two would endlessly talk about what was going to be the future of this new experiment called India. As children, they'd both seen their parents and families constantly engaged in talks and discussions and meetings, taking part in the freedom movement, and they both were keen to see what would happen to an independent India. By 1947, the war had ended and the country gains independence from the British. At this point, Sarabhai has two choices in front of him. Either go back to Cambridge and continue his work and research there and possibly become a famous physicist known all over the world, or stay in India and help decide the shape and future of science and scientific research in this country. If I were him, I would have made the same choice he did, which is to stay back in India and make its science dream come true. And when he stays back, he chooses an area of science that works well for his research ambitions, space. And this is why. Sarabhai was a cosmic ray physicist. That means he studied charged particles called cosmic rays that came from outer space and interacted with Earth's upper atmosphere. Up until now, most research had been carried out by scientists who went up in balloons to study these particles. But balloons could only go up so high, like 30 kilometers or something. If you wanted to go up any higher, you had to use rockets that could travel to much greater heights of above 100 kilometers. And it is in doing this research that India had a geographical advantage. You see, the magnetic equator of the Earth passes through India, and this made it much easier to study cosmic rays. And it wasn't just scientists from India like Sarabhai who had this idea of studying cosmic rays from the magnetic equator. Robert Millikan, an American scientist who won the Nobel Prize for his work on the charge of the electron, had come to India in the late 1930s to study cosmic rays at this location. He couldn't complete his work because the war made it difficult for him to procure instruments and setups for his experiment. But Sarabhai knew that if India were to somehow construct a rocket launching station at the magnetic equator, that would draw the attention of the whole world to conduct scientific experiments here. All he had to do was find a suitable location to build one. Now, where would that be?
Father Peter Bernard Pereira?
Yes.
Father, we have identified your church, your lands, and your village as ideal for scientific research.
Okay.
But we need your help in convincing everyone to sell their property to us and move.
I see.
Are you willing to listen to the proposition we have?
Once the scientists explained what their plans were and why, the church father was convinced. And it was he who convinced the people of his village, mainly fisherfolk, to give up their lands to this newly formed organization, the INCOSPAR, the International Committee for Space Research. This was initially the name that soon changed to ISRO, the Indian Space Research Organization. In the early 1960s, the INCOSPAR acquired this fishing village called Tumba in Trivandrum, Kerala, exactly where the Earth's magnetic equator passes. And work soon began to build a rocket launching station here. Homi Bhabha, whom I talked about in the previous chapter, had close connections with the nation's Prime Minister, Jawaharlal Nehru, because he was the head of the Indian nuclear program. And Nehru was a champion of science and strongly believed that science and scientific temper was the only way out of the challenges the nation faced, be it poverty, illiteracy, rampant superstition, or public health. And so he was more than happy to work with scientists towards this end. Bhabha was also closely in touch with Vikram Sarabhai, who now headed the Indian space program. And with his connections, he was able to acquire national resources for India's space program. Sarabhai now had the resources, ingenuity, and drive for transforming the country's space landscape, and he got to work. The first thing he did was recruit many young scientists and engineers that would not only work on the rocket technology of the day and gain experience, but would go on to become the future leaders of ISRO, such as U.R. Rao and APJ Abdul Kalam. He would also use his friendships and connections that he made at his time in Cambridge to get help and assistance for the Indian space program from other nations such as the US and the USSR. He got the help of NASA, the US Space Organization, to get training for many young engineers in the Indian space program. Around this time in 1962, the United Nations announces a sponsorship to kickstart a country's initial space program. There were many other countries trying to acquire it, like Brazil, Argentina, and India's own neighbor and rival, Pakistan. But thanks to Sarabhai's networking and ingenuity, he was able to acquire it for India, leading to the establishment of TERLS, the Tumba Equatorial Launching Station, in 1962. This sponsorship transformed Tumba into a hub of rocket activity, not only for India but for other countries that wanted to conduct their scientific experiments such as Germany, France, and Japan. India soon launched its own sounding rocket, basically a research rocket called Rohini. In 1964 alone, there were 24 rockets launched from Tumba. 25 in 1965. In fact, 800 rockets were launched from Tumba in the period between 1964 and 1975. Tumba became the most happening place for rocket science in Asia. And the biggest consequence of this was that Indian rocket scientists and engineers gained valuable experience. Sarabhai, meanwhile, was very clear about what he wanted from the Indian space program. He did not want to participate in the space race. Unlike countries like the US and the USSR, which saw space as a new domain to conquer and exert political and ideological dominance, who can send the first manned mission to space, who can land a man on the moon first. He did not want that for India. The glamour of sending men, women, and animals into space. What he wanted was to use space as a tool for the nation's development. There were many questions raised as to why India was investing so much into space when it should be tackling problems like education, poverty, public health, etc. And Sarabhai's answer was very simple. It's not despite those problems that India was investing into space. It's because of them that India should invest into space. Space held the answer to many, if not all, these questions. For instance, communication satellites could be used to transmit media for educating people that may not have access to schools. It can be used to teach more efficient farming techniques to farmers, or teach people ways to improve public health or enable public health drives such as vaccines. Remote sensing can be used to survey regions for resources and assess the state of health of crops for agriculture. Meteorology and weather satellites can be used to monitor weather and climate in agricultural economies, which India was at the time. This is not to mention all the other potential applications that could come from space technology like medicine, science, military, etc. For instance, one thing that came out of this was during the 1982 Asian Games, satellite communications helped the live telecast of games in color across the country. This led to the adoption of television sets as a commodity in middle-class Indian households and greatly contributed to the nation's economic development. Vikram Sarabhai was a man with the foresight to lay the foundation for all this, but unfortunately his own life wasn't so evergreen. In 1966, Homi Bhabha tragically died in a plane crash, and the then Prime Minister Indira Gandhi asked Sarabhai to take over the Atomic Energy Commission. This was on top of all the other titles and positions he already held. There was mounting political pressure at the time for India to acquire its own nuclear weapons because it had just been involved in military conflicts with two of its neighbors, and when Sarabhai was asked to enable this, he refused. He strongly believed that science and technology should only be used for peaceful purposes. This led to an even greater pressure added onto his shoulders. And on top of all this, he was constantly traveling to meet with his PRL team in Ahmedabad and the ISRO team in Trivandrum and national leaders in Delhi. And the pressure, unfortunately, finally got to him. On the morning of 30th December 1971, a caretaker at the guest house he was staying at in Trivandrum knocked on his door. There was no response. When the door finally opened, he was lying there peacefully, as if he was sleeping. It was an extremely sad and mournful loss for the entire nation. And for his funeral ceremony, people from all over the country gathered to take one last look at Sarabhai. The man who had given so much for the growth of science in the country was no more. But there was an even bigger problem. Without Sarabhai at the helm, what would happen to India's space program?
Hello.
Sir Vikram Sarabhai is no more, and the Prime Minister wants you to take charge of ISRO. She wants you to meet her.
The man receiving the call was none other than Satish Dhawan, an aeronautical engineer and the then director of the Indian Institute of Science. And pretty soon, he did come to meet the Prime Minister Indira Gandhi and accepted the responsibility of heading the Indian space program, but under two conditions. He wanted to remain the director of IISc Bangalore, and he wanted the headquarters of ISRO to move to Bangalore so he could continue his work in IISc while heading the space program. Indira Gandhi knew how much of a capable man Dhawan was because she was aware of the work he had done in previous positions he held, and she was keen on having him as the head of the ISRO. She accepted both conditions, and Dhawan soon took the mantle of the chairman of ISRO in 1972. And Gandhi wasn't wrong about Dhawan because ISRO grew to spectacular new heights under his leadership. Some might argue that Dhawan was as capable, if not more, than Sarabhai himself. He certainly had the same vision for the space program as Sarabhai. And in addition, what he brought in was a more formal and organized management style to ISRO. What Sarabhai had was a more informal style of management where he sanctioned projects and assigned it to people with whom he mostly had a one-on-one relationship without focusing much on structure. And this is where Dhawan was different. With his superior managerial ability, he was able to take on multiple projects like engine and fuel designs, satellite design, launch vehicle design, etc. And he assigned capable people as mission directors for each department. One of these missions was the launch of India's first satellite called Aryabhata, launched in 1975 under the leadership of U.R. Rao. It was launched in collaboration with the USSR using the Cosmos 3M launch vehicle. After the success of the Aryabhata satellite, U.R. Rao would go on to head multiple other satellite projects such as the Bhaskara, Apple, Rohini, and the INSAT series of satellites, earning him the nickname the Satellite Man of India. He would also go on to serve as ISRO's chairman after Dhawan. Let's get back to Dhawan. He undertook another project parallel to the development of these satellites. India wanted to develop the capability to launch these satellites by itself. But this was a whole new challenge compared to the sounding rockets it was launching till then. See, sounding rockets just had to fly straight up and carry out their measurements. But launch vehicles had to do a lot more. They have to follow a certain path that would take them eastwards. They then have to reach the required height of the orbit and then inject the satellite at the right angle and the right speed into the orbit. And this speed would be in the order of several kilometers per second. So just imagine, a rocket has to be accelerated from 0 to several kilometers per second. Imagine the engineering required to handle the kind of stress on that vehicle. As if this wasn't enough of a challenge, there was more. The path would have to be eastwards because the Earth rotates eastwards. That's why the sun rises in the east. We can take advantage of the Earth's eastward rotation because it gives a speed boost to rockets when launching something eastwards into an orbit. This eastward path meant that a launching station on the east coast would be ideal because we had the Bay of Bengal to the east, and any rocket launch eastwards would be above the sea and not above towns and villages. And ISRO soon found this launching station of Sriharikota in Andhra Pradesh. And as soon as it did, India began a program to develop launch vehicles, the first of which was the SLV-3. And the mission director for this project was none other than APJ Abdul Kalam, who would eventually go on to become the president of India. There's a really inspiring story about the leadership qualities of Satish Dhawan. When the SLV was first launched, the mission was a failure. The rocket launch was unsuccessful and crashed into the Bay of Bengal. Kalam and his team had detected a leak in the fuel tank that caused the failure but allowed the launch to take place anyway, thinking the leak was insignificant, leading to the crash. When it came time to talk to the press about this, Dhawan came forward and talked to the press and took responsibility for the crash, basically shielding Kalam and team from them. But a year later, when SLV was launched again and was successful this time, Dhawan let Kalam and team take all the glory for the success of the mission. I think this story exemplifies the qualities of a great leader in Dhawan. His actions were something that inspired loyalty in those who worked under him, and this helped him grow ISRO into the monumental organization that it is today. The SLV project laid the groundwork for future launch vehicles like the PSLV and the GSLV, which were extensively used by ISRO for its satellite and space probe missions. For instance, the Chandrayaan-1, a probe designed to explore and survey the moon, launched aboard the PSLV XL launcher in 2008 and discovered the presence of water on the moon's south pole. The Mangalyaan mission, a Mars orbiter launched aboard the PSLV XL in 2013, successfully went into Mars's orbit in 2014, with its primary objective being to observe and study the surface features of Mars. With this mission, India also became the first country to achieve this feat in its very first attempt, and that too at a fraction of the cost of similar missions by other space agencies. With With these successes under its belt, ISRO now plans an ambitious mission called Gaganyaan, a mission to send astronauts into space. The mission is scheduled to launch in 2025, and you can bet I'll make a detailed video on it at the time of launch. I can confidently say at this point that India has a thriving rocket launch program, all thanks to the people currently running it and the ones who got it to where it is today. If Sarabhai were alive today, he would be proud. My objective with this channel is to bring out stories like these that inspire me and probably inspire you too if you're still here watching. I believe that you and I can love and appreciate science outside of classrooms and exams. If you love my content, you can choose to support me using the links given below. And if you choose to give me continued support, you'll get a really sweet deal. If you become a member on Patreon or YouTube in the connoisseur tier or above, not only do you get exclusive access to my WhatsApp group, you'll get access to one or more companion videos that I release with every one of these main documentary videos. Along with this video, I made an exclusive video called Spaceflight. Here's a short clip from that.
It'll fall down, fall down, fall down. But hey, where's the Earth? It's not hitting the ground. Oh, the Earth is over there. Okay, fall that way, fall down, fall down, fall down. Hey, where's the Earth now? It's not hitting the ground. Okay, so that's the thing. It tries to keep falling and hit the ground, but it keeps missing the Earth. It keeps going around the Earth even though it's falling. This is what it means to be in orbit.
Now, these companion videos will be every bit as high effort and edited as the main videos, and I should probably release them on my main channel, but I won't. They'll be an exclusive to those who support me in the connoisseur tier or above. The people who have already given me support, especially the ones who give me continued support, particularly my high tier patrons, you have my eternal gratitude. With your help, I'll be able to hire more people, hire a team, and produce these videos more frequently. That is my aim. You can also check out my channel called DD Rational, where I promote rational thinking. And if you can't financially support me, that's completely fine. Just share this video on social media and help it with the algorithm. If you like this video, you might like this similar video I made on the story of nuclear science in India. I'll see you in the next one. Till then, remember, science is dope.